probably everyone's aware that amino acids are the building blocks of proteins, and the amino acids are linked through peptide bonds. So remember that a peptide bond is an amide. That's the peptide bond, and an amide is a functional group with a carbonyl carbon connected to a NH. So every time you have a link between two amino acids, you're going to have this peptide bond, and that nitrogen has 3 bonds. It's always neutral charged, and it always has a hydrogen, except for one amino acid. There's one amino acid that has no hydrogen on the nitrogen, and this was a mistake that I found on the exam last semester. Which amino acid do you think? Remember I told you there's always 2 to guess when there's an exception.
Glycine?
Glycine's 1 to guess, but that affects the alpha proton.
Is it proline?
Proline.
It's proline. Yeah, because proline has that ring coming in there. And so for proline, it's going to look like this. And that already has 3 bonds. So there's no hydrogen on the peptide bond with proline. Not a huge thing, just like to point it out in advance.
But that's still a peptide bond?
Yes.
technically?
Yeah.
Okay.
It's highly strained and it causes kinks. It limits the flexibility of the protein backbone. But it's still considered a peptide bond.
You used the word amide. What was that again?
Oh, an amide is a functional group where you have a carbonyl attached to a nitrogen. I don't know if you remember esters. Esters are where you have a carbonyl. Carbonyl is C double bond O with an oxygen in the ring or in the middle of a group. That's an ester, and an amide is like an ester. It's just that the O gets replaced with an N. So peptide bonds are amides. And so here is the structure of a peptide. And I want you to get used to looking at these. Peptides are drawn from the amino end to the carboxy end, from left to right. So this is called the amino terminal residue. Oh, residue is another word for amino acid. I don't know why. I don't know the origin of the term residue, but it's more commonly used than amino acids most of the time. Okay, so what I'll want you to do is be able to find all the peptide bonds and identify the sequence of the peptide. Right, so there is one peptide bond. There is another one. There's another one. And so this is showing, to get the sequence of this peptide, you would look at all the R groups in order, and that would tell you the sequence of the peptide. So this is a peptide that has 6 amino acids because there are 6 R groups. And we can't tell what the sequence is because all the R groups are just written as R, but you'd have to identify them. And that's what that speed amino acid quiz is designed to get you to learn to find the R groups.
Is there a reason you include the oxygen and the hydrogen in the bond? Or isn't it just the bond between the carbon and the nitrogen?
Oh, that's a good question. Yes. So you're right. The peptide bond is the CN bond. But I think, so the CO and the NH, everything that I've boxed is a plane. It's like a piece of paper. And that restricts the conformational space that the long polypeptide backbone can fold. And so we think of them as like little planes kind of linked together.
I see, cool.
Yeah, and actually that is shown here. So this is just a zoom in on a peptide bond. And this is showing it as I've drawn it, but there is resonance. So that nitrogen, right, that nitrogen has a lone pair. And there's resonance where that lone pair electrons spend time in between the CN bond. And this other structure here is also present in solution. And they estimate that, I believe that this is about 40% of the character, and this is 60% of the character of the peptide bond. And so what that means is that there's no rotation around the peptide bond because of remember, you cannot rotate around a double bond. And so, because it's like a ladder, right? You can't twist the rungs of a ladder into a helix because the ladder is rigid. So there's no rotation there. And so that's what gives it rise to being planar and rigid, that double bond character. And
So
they know,
even though it's a resonance structure, it still can't move because of the double bond.
yeah. Yeah, so it's like 40% double bond, right? So these are two snapshots of what's there, but really in real time, those electrons are mobile. And we know that this exists because we know what a carbon nitrogen bond length should be if it's single. And we know what a carbon nitrogen bond length is if it's double bond, it's shorter. Double bonds are shorter than single bonds. And based on the bond length between that carbon and the nitrogen, we know that it's got about 40% double bond character. Okay. So then there are small peptides which have physiological activity. Some peptides are hormones.